Here we are again, Kevin Culp from Supermicro, basically bringing another use case in regards to liquid data centers. Here at Supermicro, we're driving the AI revolution by preparing liquid-cooled data centers for the sustainable future. Our use case will focus on liquid-cooled data center and also a new feature we're building in, which is basically the liquid cooling tower lifecycle management. You'll see that in the next subsequent videos where we'll actually provide you with our liquid cooling tower lifecycle management. In the front of the web GUI here, our landing page, we've animated our SuperCloud Composer, made some changes and optimization within our platform to give a better futuristic view of where we're going in regards to SuperCloud Composer. So I had the liberty of basically plugging into our Building 23 liquid cool production facility. We have one in Taiwan and one in San Jose. This one we're actually looking at some liquid cooled servers, GPU servers, in fact 4U AMD servers, where we'll actually show some pretty cool things in regards to what we're doing here with SuperCloud Composer, providing essential lifecycle management of building out critical superpods for NVIDIA itself. So let's get started. We'll log into the dashboard itself. So this is version 3.40. That is soon to be released into production here within the next couple of weeks. So I thought I'd give you a quick sneak preview of our pre-release software and show the use case around liquid-cooled data centers, which is our second phase that we've built into our use case for liquid-cooled solutions. So let's log into the platform itself. We'll log in as global admin. So give me a second here so I can log in. And when you log in, you are taken directly to the front dashboard. So one of the things I'd like to point out is we have now adopted and implemented essentially what we refer to as online help. So any task that you're not familiar on how to do, we'll provide online help that you can index and quickly determine how you would perform a task depending on what type of role that you have in the data center, whether you're a server architect, a network administrator, a data scientist, or an infrastructure DC admin. You'll see later how we've optimized our role-based access control to bring in new use cases around the need to know and showing data that's important to specific roles. So let's jump into the data center in itself for the liquid cooled. So the first thing I'm going to launch into is PodView, which is really our signature hallmark feature within SuperCloud Composer. Customers absolutely love this particular feature because it really gives them a visual representation of how servers are assigned, are associated with a liquid cooled rack. You'll see here we have 8 of the 4U AMD. What's unique for this value proposition or this use case is our rack team performs L10 and L11 services. Nobody in the industry can do this, where when you look at the back of this particular rack, you'll see various different kind of cables, things like hoses that you have to be able to completely pack into this rack, cables as it relates to Ethernet connections for Ethernet switches for BC management, InfiniBand connections going into the data plan, and even PDUs that are present. So just a whole lot of cables that are inside this rack, and our L10 and L12 rack team does a tremendous job of basically pre-populating these and shipping them out as a pallet as one entire rack that gets shipped to our customers itself. So we have 8 of the 4U AMD GPUs here. You can see here on the bottom here represents what I'm pointing to here as the GPU manifold, and then you have basically the CPUs themselves. What's interesting with this use case is that when you click on each one of these, it provides you with the SKU, the serial number, the IP address of the BMC, and also the rack slot unit that is where it actually starts. So it's in a 4U, so it starts at position 41 and occupies 4 slots within the rack itself. Always the CDU is present at the rack slot unit 1 of the rack itself on the bottom of the enclosure, and by hovering over to the tooltip, we can look at or discern special information about the serial number and also the SKU and also the IP address. On the top here, we have a rack that is managed through a PDU. This is a Schneider Electric PDU. We have support for universal agents to support Legrand, Server Tech, and then also Eaton. So depending on your use case and your favorite PDU manufacturer, we provide that level of lifecycle management support for PDUs. You can check out our PDU management YouTube video that discusses what we provide for lifecycle management of a PDU. And then in the right-hand side, we show it's also managed through a CDU, which is really the brains of the outfit, where water comes through the CDU from a input source and then has a return source. And those are color-coded on the manifold of each of the racks to indicate the supply chains. And by the way, if you get those mixed up, we provide alert management to indicate that the cables are backwards and things like that for that use case. So we have a liquid-cooled console here for an IP address of the BMC of 10.43.240.68 and also our SKU. So if we wanted to take a look at the rear view of this unit itself, we can show you both the front view and the rear view. You'll notice here that we are managed through PDU information on the right-hand side, and then also CDU information itself. So this is showing you the front and rear view of the rack itself, and then the images associated with the servers for front and rear view. So if you wanted to look at the tree view, so the tree view is indicating the rack slot unit. You can see here we have the rack slot unit 4.1, which is our liquid cooled CDU, and then we have each one of the systems themselves which are in the drawer on the left hand side of the tree view itself. And if you wanted to look at one of these from the tree view perspective, you could click on the drawer information. It would show you drawer information, showing you the front and rear view, showing you information here for drawer information. And then you can simply click here. Any of those things would be discovered through our SSDP functionality. So all of Supermicro BMCs have SSDP enabled, so they can perform device discovery. And if you wanted to click on the 10.43, which is in rack slot unit 6, you see additional detailed information indicating serial number, MAC address of the BMC, being able to connect into the BMC IP address, SKU information, and so on and so forth. So if you were to click here, you could directly get connected into the BMC and perform any type of BMC task that you wanted. Most of the tasks within SuperCloud Composer are part of the management platform, We want to minimize the number of clicks it takes to get into the BMC, so we provide all of that BMC functionality within SCC as the management platform. And you can see here that we have icons to indicate a PDU and a liquid-cooled CDU itself. So that's in a nutshell how we actually look at pod view, which is our representation or visually representing our liquid-cooled data center of a number of racks. So now we're going to enter and drill down deeper into the liquid cooling console itself. So if you click on the location, we provide the front view and rear view. We show you additional information here about the CDU. If you were to click here, you can perform firmware updates to the CDU, as well as connecting into the BMC of the CDU. And on the carousel view on the top, we're representing coolant return temperature and supply temperature. So if you wanted to stop the scrolling, you simply would place your mouse over the carousel view in the box. The scrolling would stop. And then if you removed your mouse, it would continue to scroll in 5-second intervals. So that's on the physical asset information for the liquid cooling console. We're now going to go to sensor reading information. This is showing you operationally how the CDU is performing. So these types of CDUs are live and providing liquid cooled use cases for our GPU servers themselves. And then also, if you click on the analytics, let's scroll down a bit here and we can show coolant return temperature, supply temperature. We saw other sensor data that you can collect here in regards to facility water return temperature, left valve and coolant pressure, so on and so forth. So all of this is available to you. Your humidity sensor reading, heat dissipated, dew point, all of these are real-time values that are being pulled from our production facility, which we're testing these liquid-cooled racks that are being shipped out to customers. Moving on to the analytics piece of things, shows you operationally the status of the CDU, what's happening with the power, the pump and valve and sensor and humidity data. And then we also have coolant monitoring sensors that we're looking at liquid level, and then you see delta values for temperature that are shown through time slots or delta values within time, where you can move across here and look at the real live values themselves, and we basically chart them. So if you click on the temp ambient, you notice that the other data points or ones we're charting go into the background, and the temp ambient becomes the foreground, so you can easily view what kind of metadata that you're looking at within the platform itself, or within the your lifecycle management of the CDU. So let's scroll down into the sidecar and look at leak protection. So in the server aspect of things, we have, if you recall, we had 8 particular AMD platforms, which are GPUs for you. And if you wanted to click on all of them, you could basically set up your enforcement policy as an administrator of what you want to set. You can set different values as far as what kind of enforcement action that you want to perform. Some no action, immediate shutdown, or graceful shutdown. And of course, we also allow you to set a value, a delay time. Perhaps you have some storage servers that you want to shut down, or you're running some type of LL model or inferencing model, and you wanted to delay the operation of shutdown if a leak was basically detected. So we, as in the SCC appliance, don't enforce that leak enforcement action. You, as the administrator, set the policy and drive the policy. So we leave it flexible for you. Perhaps you may want to have just a few that are going to be set for enforcement policy, and maybe the other ones you don't want to support enforcement policy. But we provide that flexibility to you for the administrator to set those enforcement policies. On the top right here, we indicate here where you can actually set the two leak detection sensors, which are sensor 1 and sensor 2. These are outside external to the CDU, so perhaps you could take a sensor, wrap it around your supply chain or your supply source that goes out to your liquid-cooled tower. If there was some type of leak in the hose, we would detect that and immediately set the enforcement action depending on what you wanted to set. And then maybe you could strategically place the sensor in a different location to be able to look at a leak when it's detected. So the next phase, again, will provide enforcement action to cut power to the entire rack based on when we complete our universal agent for PDUs. Themselves will set an enforcement action to cut auxiliary power to the entire rack. But again, we will allow you as an administrator to decide what enforcement policy that you want to institute. So those are external to the rack. So you probably are saying, well, gee, what happens if there's a leak on the cold plate itself or on top of the CPU? So in that particular use case, the BMC becomes the enforcement action to shut down that particular server if the sensor was triggered on the cold plate itself. So we don't get into a situation where there's a tug of war where perhaps you had a liquid cooled or basically a leak protection or leak detection occurred outside. You would shut down or make those policy driven decisions that you want. And then if there was a leak that was detected at the cold plate, the BMC would enforce that action. So clearly there's a delineation between when there's a leak inside the server and when there's one that's outside the server itself. Okay, so those are the two leaks detection sensors. We have them disabled. We're not going to test basically a leak detection to occur. We would probably need to have somebody locally at the rack dip the sensor into water, maybe perhaps use a sponge, enforce the enforcement action, and then you could watch the servers power down and make a decision based on your enforcement policy. Okay, so that's on the server side. So all of these 8 are associated with that liquid-cooled rack. And we allow you to make changes dependent on what your enforcement policy is. So moving to CDU, again, here is where we set the emergency stop settings for leak detection, both sensor 1 and sensor 2. So you would check those and set the enforcement policy itself. And then on the operational mode, we can control the flow rate and also the valve operation dependent on these settings that you set here within the liquid cooling console itself. So in a nutshell, that is the liquid cooled data center from a rack perspective. Next video, we'll talk about sensor data specific to the liquid cooling tower itself. Thanks for joining. We'll see you next time where we'll show you the liquid cooling tower lifecycle management. Thanks again.